Hi, this is Francis from A+ Tutoring. In this session, I'm going to show you limit comparison tests. Now, in this example here, I want to compare with something that I know of, right? I would take the top part like this. I'll still take the square root of n over n squared because I don't care about the 1. I want to compare with something like this. Now, if you simplify this a little, this is going to give you something like this. 1 over n to the power of 3/2. Now, you know that this is converging by P series. Why is that? Because P is basically your 3/2. P is equal to 3/2, and which is bigger than 1. So therefore, my series converges by P series. Now that I know something that I want to compare is converging, I want to take the limit. Okay, so if you look at the notes here, the limit n approaching to infinity of this an over bn, the one that you compare, you want to put them in the denominator. Okay, if it's equal to a number then which is bigger than 0, so that it converges. Because your bn, the one that you choose, is converging. Now, if in the other case, if the one that you chose is diverging and you take the limit and it's equal to a number which is bigger than 0, then it also diverges. It follows the one that you compare with. Okay, all the other case, that means you have to find another test. So in this case, I would expect that if I divide it, then if it's equal to a number, then it converges. Now, so let's do this. Limit of n approaching to infinity. This is the one that is on top. And divided by the one that I want to compare with, which is this one. So I want to flip it, right? Because I divided, so I multiply the inverse. So this is going to be limit of n approaching to infinity, square root of n over 1 plus n squared times n squared over square root of n. Now this cancel out, right? And then you have n squared over n squared here. You know that the limit is going to be 1. Because this is going to become something like this, which has the same degree on top and bottom. So the answer of this is going to be equals to 1. And which is, if you look at this, which is bigger than 0. Okay, so this is bigger than 0. Okay, therefore, my series converges because my series that is comparing is also converging. So this converges by limit comparison tests. For more information about limit comparison tests, please visit my website, go4aplus.com.